All right, so what we're going to be covering today is more similar triangles. And remember last time you guys learned angle similarity. That shows that if you have two triangles and you have two sets of angles congruent, then you can say that they are similar, means that they're the same shape, except one might be a different size. They're proportional, because the third angle would also have to be congruent. That was what we talked about last class. Now what we're going to be going over today is something called, on the notes that you should have printed out in front of you, the notes talk about, first thing is side, side, side. So remember from triangle congruence, if you have side, side, side congruency, that means that both triangles are exactly the same if all three sides are congruent. But if you look in your notes, it has to do with a scale factor. So I give you, let's take this. Let's just say this is 3, this is 8, and this is 7. Okay, and let's say I divide this by 2. So this is 1.5, 4, and 3.5. These triangles would be considered similar because they have the exact same scale factor. Meaning, half of 3 is 1.5, half of 8 is 4, half of 7 is 3.5. So that means all those triangles are similar. This and this are similar. Now what side, side, side does is it tells you if you take two sides of one triangle, 3/7, and you take the same two sides on the other triangle and you set them up as a proportion, when you cross multiply, 3 times 3.5 will equal 7 times 1.5. That means that if all the sides are proportional to the same exact sides, the corresponding sides on the other triangle, then side, side, side is the similarity conjecture that makes them similar. Okay, now with that, I talked to you about something called a scale factor. So let's take the example that I give you in the book, or in the notes. I give you a triangle, 4, 6, and 10, and then I give you a little tiny one, and I say the sides on this one are 3, 2, and 5. And then the question is, are these two similar? Well, right off the bat, I know a lot of people would say, okay, well, let's say 4/10, does that equal 3/5? And then when you cross multiply, 5 times 4 is 20, 10 times 3 is 30. So a lot of people would say, no, it's not, because they're not proportional. So I cannot say they're similar because of side, side, side. That's incorrect. Okay, so look at this. Sometimes they're not always going to give you the triangles in the exact same order. Let's take this triangle right here, and let's say I flip it over. I just take this and I flip it. So the sides are, I'm going to redraw this triangle. This is a 5. Because if I flip it, the bottom side's still 5. This 2 comes over here, and this 3 comes over here. Because technically, if I have like any shape in my hand, I can just take it and move it. It's still the same exact shape, except the sides are on different parts now, or on different sides. This side, if I flip it, it's over here. I don't have to have it lined up exactly the same. Now let's look. Now let's take these same two sides, 4/10, and let's set them equal to 2/5. And when you do this now, 5 times 4 does equal 2 times 10. Then if you were to go 6/10 equals 3/5 and cross multiply, those would equal each other as well. So these two triangles are similar because they have the exact same scale factor. How do you know they have the same scale factor? Because half of 4 is 2, half of 6 is 3, half of 10 is 5. But you have to state what triangle conjecture makes them similar. And it's side, side, side. The definition of side, side, side on your notes says if all the sides of the triangle are proportional to the corresponding sides of the other triangle, meaning when you set them as a proportion and you cross multiply and they equal each other, then side, side, side makes them similar. Okay, so the next conjecture that we're going to talk about is side, angle, side. Side, angle, side. Now, if you remember with triangle congruency, if you have two triangles with an included side, an included angle, meaning where the two triangles come down, boom, that angle right there is congruent where the two sides are meet, then they're the exact same triangle. And it's kind of similar to this. But if you read in your notes that you should have in front of you, that I gave you, it says two sides and an angle in between them. Means they have to be proportional. So look, I give you two triangles, and I keep the numbers pretty simple. This is 4, and this is 5, and this is 12, and this is 15. Are these triangles similar, meaning are they the same shape except different sizes? Well, I can either prove it with angle, angle. I only have one angle in each one of these. I don't have a second angle, so I can't use that. I can prove it with side, side, side. I only have two sides and two sides. I can't use side, side. I don't know what this side is and this side is. So, and I don't know what this angle degree is, so I can't figure out what these two sides are. So I would have to see if it's similar because of side, angle, side. Now what side, angle, side says, if you take two sides of one triangle and set them equal to the exact same two sides as the other triangle, as long as they both have an included angle, meaning a congruent angle in between both of them, then they would be similar. So does 4 over 5 equal 12 over 15? Well, let's cross multiply. 5 times 12 is 60. 4 times 15 is 60. So these two triangles would be similar because of side, angle, side. In your worksheet, it's going to ask you to label the triangles similar in, like, for example, if this was A, B, C, and this was X, Y, Z, they would want you to write out a similarity statement, like triangle ABC is congruent to triangle XYZ. I don't care about any of that. All I care about is you telling me what conjecture makes them similar. That's it. And if they're not similar, you're not going to say CBD. You're just going to say, no, they're not similar. All right, so let's look at the very first example. I give you a lot of examples, and all I'm going to ask you is what conjecture makes them similar. So I'm going to write up the three conjectures right here. The first one is angle, angle, side, 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 and side, angle, side. These are the only three conjectures that make triangles similar. That's it. Just these three conjectures. All right, so with that, let's check it out. The first one. You should be able to tell right off the bat these two are not similar. The reason why they're not similar is because this is an isosceles triangle, this isn't. They're not the same shape. But if you wanted to back it up mathematically, you could say 39 over 40, does that equal 16 over 16? And 40 times 16 is not the same thing as 39 times 16. Two different numbers. So mathematically, they are not similar. So you would say no. Next one. I give you two triangles. They could be right triangles. I don't know. I don't know if Pythagorean theorem is right for them, but let's look. 12, 14, 8, 48, 84, 72. All right. So you can set up a proportion, and you could say, does 84 over 48 equal 14 over 8? Cross multiply, these two are going to equal each other. And then you would also have to say 70, you have to include all three sides, because sometimes the third side will not be proportional. You have to say 72 over, let's say, 48, does that equal 12 over 8? Which it would. But the easier way to see if side, so side is the answer that makes them similar. But the easier way to see if they are similar is look at this scale factor. I think that's way, way easier. Look, 8 times 6 is 48. 14 times 6 is 84. 12 times 6 is 72. The scale factor is 6, so this is 1/6 the size of this. Or this one is 6 times the size. So the answer would be, well, the question is, are they similar? The answer is yes, by side, side, side. Because if they had the same scale factor, you can set them up as a proportion. Now there's two more. Look at the third one. There's nothing to set up on the third one. But you should see that there's two angles in one triangle. There's two angles in the other triangle that are congruent. So therefore, angle R and angle P would have to be the same, making angle the only one that you could use. You couldn't use these two because you don't know any information about any of the sides to set up a proportion. But the last one, you do know. Okay, so the last one is 71 degrees, 71 degrees, 9, 18, 21, 42. Okay, so you should look at this right at the bat and go, well, I know that I can't use angle because I don't know another angle. I can't use side. Well, technically you could if you knew the law of cosines, which you're not going to learn in this class. But you can't use side right now. You're not going to learn that until Math 3, by the way. So if you're like, what the heck is law of cosines? Don't worry about it. That's not until another year from now. So right now, with everything, all you can use is side angle side. Now, how do I know if these are similar? Well, I have to set up a proportion. I'm going to say 9 over 18. My small side over my larger side equals my small side over my larger side on this one. 21 over 42. You can't say this, 9 over 18 equals 42 over 21. You have to go in the same order. If you use the small side and the bigger side of the one triangle, you have to use the small side and bigger side of the other triangle in the same exact order. All right, so, well, you should be able to tell, first off, well, if you have a calculator, look, 9 times 42 does equal 21 times 18, but look, 9 over 18 reduces to 1/2. 21 over 42 equals to 1/2, so both of these fractions are the same. Side angle side would make them similar. Or mathematically, if you didn't know this is 1/2, you could just cross multiply. 9 times 42, yes, does equal 18 times 21. So today you're going to be doing a worksheet. There's I think there's a couple different pages. And all you're doing is you're listing, I think the directions, let me see. So it says, state if the triangles in each pair are similar. If so, state how you know they're similar and complete the similarity statement. When it says complete the similarity statement, I don't want you to complete that. That's when you say triangle blah, blah, blah is similar to triangle blah, 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 and you list it in exact order. All I care about right now is you stating either yes, they're similar by one of the three conjectures or no, they're not similar.